Today we're going to explore how to set up Softbody physics, and to get us started I'm going to jump to Blender and I'm having this basic scene here. Before exporting, I want to make sure that all the object that will be used as Softbody, these ones here, have the origin that is set in the center of the object. And I also want to make sure that I reset the rotation and scale for these objects. Next, I am going to export my scene. So File, Export, and GLTF. On my desktop here, I'm going to include the selected object. Ensure that we are not using Y up. And for the geometry, UV normals, tangent, and vertex color, I am simply going to export that. Back inside the NRG editor, I am going to create a new project using a default template. I am going to ensure that physics simulation is on, and I am going to place the project on my desktop here. I'm going to jump straight editing my first render layer, select the library, asset import, and I am going to search my GLB file here. And another important thing when dealing with Softbody physics, we want to make sure that there is no duplicated vertices. So ensure that this is set to an acceptable value. And now we are ready to import our scene. So first thing we have to do is to set up that this ground here will be a static mesh, since our objects will fall and needs to have some sort of ground to fall on. So what I'm going to do is I'm going to tune down a bit the base color of this material here so we can get visualization. And what I'm going to do is with my ground selected here, I'm going to go under the Physics tab and I'm going to add Static Physic to it. I am going to jump to wireframe quickly and I'm going to add two collider, one box for the ground and another one for the little bump that we have here. So add collider box, and I want to specify that it would be considered as a compound shape. I am going to go in the transform and I'm simply going to align it as much as possible with my ground. And I am now going to create a second box. Same thing here. I'm going to put that the size is 1 by 1. And I'm also going to transform it to align it with my bump here. So using the location slider, I am going to align it. If I go from the top, probably easier. Something over here. Doesn't have to be rocket science. And that's about it. Next is to set up our Softbody physics. First, we're going to work on this object here. That will be a single cloth. So what I'm going to do is by default, since I'm on the Physics tab, by default, if I want to add physics to this guy, since it is a static mesh, I only have static and rigid body available. In order to apply Softbody on a specific object, this object have to be of the type dynamic mesh. So with that object selected, I'm going to go on through selection, convert to, and dynamic mesh. And as I push add physics again, I have now the option for Softbody physics. I'm going to have a first run at it to check how this one behaves. And I'm going to hold shift and push play. And right away, we can see that we got relatively proper cloth physics applied. You can see that here, it's because of we don't have enough subdivision. We can see that here, the cube, the ground before is showing. So what we can do to fix that, all we have to do is to increase the collision margin of that Softbody, which is at default at 0.8. If I put that at 0.16 and run it again, we can see that now that pretty much fixed the issue. Most of the time when you're having a cloth, you want this cloth to be attached somewhere. So what we're going to do here, offset it a bit. And what we are going to do, we are going to add some pins, some constraint to it. So I'm going to jump right at the bottom of my Softbody properties and I'm going to add a constraint of the type pin, open that up, and a pin will create us a point where our Softbody is attached. It's going to set the mass of the nearest node to 0. So what I'm going to do, I'm going to use the slider here, and it doesn't matter even if we go overboard, it would snap automatically to the closest node. And I am going to place it here. I'm going to create a second one. Same thing. Get a better visualization. drag it over a bit more, and I am ready to have another test run. If I hold shift and play, we can see that now we have our cloth that it's hang over here. And another thing that we probably want to do to make it more vivid, we want to have some wind that will be applied on that cloth. Instead, it's simply going to deactivate like this, which doesn't give us a very realistic effect. So, of course, we could use here the wind direction velocity vector of the Softbody, but I found it more convenient to actually add an energy field of the type wind. So to do that, I am going to go under Object, Add to Scene, and an energy field of the type wind. I am going to drag it over so it can be in range with my cloth here. And I am going to rotate it slightly so the wind will push in this direction. Accessing its properties, I am going to put the strength at something like 0.15, not too much. And for the attenuation, I'm going to select linear. So the closest to the center, the more wind, and the more far we go, the less wind will be applied. And I'm going to also increase the radius slightly, something like 2.5, and maybe align that a bit more. So like that, the wind will push this direction. And the final step to make this work, we need to enable that our energy field will take in consideration dynamic mesh. Now, if I run that again, we can see that now we got wind that it's applied. And as I move my energy field, we can see that now the cloth is directly affected by it. Next, let's simulate something more of a ball bouncing. So I'm going to go over to my ball here and I'm going to repeat the same process. I'm going to go under Selection, Convert to Dynamic Mesh, and jump to my physics properties and add Softbody physics to it. If I have a test run, we're going to see that it just melt on the floor, just like the cloth. By default, cloth physics settings are applied to it. What we want to have is something that is going to conserve more of its initial form. So what we're going to do for that, we're going to need to use bending constraint. What I'm going to do, I am first going to set a mass to it. So let's say 10. So we got something that is more consistent. And we are going to jump over to the options and we're going to generate generic bending constraint for this object. And right away, if we have a run at it, we can see that now it just splashed like that. There's no real deformation that it's applied on it. We could also increase the amount of iteration to have a more accurate simulation. And the next step that we need to do is to apply some sort of stiffness to it to control the linear stiffness of this object as it is pretty stiff right now. And to do that, what we're going to do, there's multiple ways of doing it. The easiest way probably to do it is to create a physics material for this object and use the linear stiffness properties to control how much impact the deformation will have on our object. So to do that, I am going to select my library, asset, and new physics material. And right here, I am going to turn down the linear stiffness. By default, the generic bending constraints are pretty stiff to begin with. So I'm going to leave it to 1 actually at first. And I am going to now set up my physics material. And as I run, not much difference so far. If we go under the physics material properties, pull it. And now I'm going to drag it at, let's say 50%, run that again. We can see that now it starts to deform a bit more. It starts to get some sort of absorption when it hit the ground here. We want to go more far than this. So let's say that we put it at 0.123 and run it again. And we can see that now there is a drastic change when it hit the ground, absorbing and deforming. I can tweak it even more down to display the impact. Now it's really absorbing the shock, just like that. Let's leave it at 0.125, which give basically good result. I am going to stop and I am going to go under File and apply my runtime change. So all the different settings that I've set will be taken in consideration, just as the position and my in example 0.125 linear stiffness. And finally, I'm going to work on my monkey here. And the monkey, we're going to use a different type of approach to handle that soft body. So first step, we are going to go under selection, convert to in a dynamic mesh. And next, physics tab, add physics, soft body. And I'm going to add a mass to it straight. And I want this mass to be a total mass. So instead of spreading the 10 kilo, assuming that it's 10 kilo, the 10 kilo over each and every vertices, I'm going to have an overall mass of 10. And I am now going to go under my bending constraint, and I am going to this time generate a generic one. You can see that now, since this object have quite a bit of vertices, it's a lot slower to generate those generic constraint. And I'm going to have a first run at it. It's behaving properly. We can see that it is stiffed a bit, but now we're losing the eye because the eyes are not connected, as you can see here. So every time our Suzanne will fall down, it will lose his eyes in the process, which is not really what we want. So what we want is to keep this volume in place while the soft body physics is applied. So for that, we're going to use the optimize bending constraint, and we are going to use the volume settings. We are going to set the frame. So like that, we are going to have intermediate position that are generated in between those vertices. And right away, if I run, we can see that she splashed, but at least the eyes seems to be still attached here. So the next thing that we want to do is to add some sort of conservation, some to match our initial position of that frame here. And as I set it to 1, we can see that now the physics applied on it look a lot more realistic. And if we want to have it a bit more smushy, we can always drag that slider and repeat the process. And we can see that now there's a lot more absorption on the individual node. Let's set something to 0.125 to have something that is comparable to our ball here that we initialized earlier. And if I slightly drag it up and repeat, we're going to see the effect that this thing have. We can see that now our Suzanne is very elastic and bounce on the floor. I hope that was helpful and give you a good idea how to set up soft body physics.